This is a video for AQA Further Pure Mathematics, Sequences and Series, section 4.3, which is looking at the application of Maclaurin series to the evaluation of limits. We're given a function of x, then we often want to be able to evaluate that function at particular values of x. So let's look at this example where we've got f of x is e to the power 3x minus 1 minus 3x all divided by x squared. So if we wanted to evaluate the value of f of x when x is equal to negative 1, it's simply a case of substituting negative 1 into there. So we get e to the negative 3 minus 1 and then plus 3 divided by negative 1 squared. And that then is equal to e to the power negative 3 plus 2. So quite straightforward. But what about f of 0? Well, if we look at that, we get e to the power 0 minus 1 and then minus 0 and 0 to the power 0, or 0 to the power 2 rather. The top line is 1 minus 1, which is 0, so we get 0 divided by 0. Now this is something that we can't actually determine. We can't say it's any particular value. In fact, we don't know what it is. However, what we could do to get an insight of this is to have a look at what the graph looks like. And if we sketch the graph, we can see it certainly appears to have some value when x is equal to 0. So as we can actually evaluate the function for other values of x than 0, then one approach would be to say, well, what's the limit of f of x as x gets closer to 0? So for this particular function then we're saying that f of 0 will be equal to the limit as x approaches 0 of e to the 3x minus 1 minus 3x all over x squared. Because that doesn't really help us unless we can find some way of expressing this rather differently. And this is where the Maclaurin series come in. The first thing we need to do is to get an expression for e to the 3x using the standard Maclaurin series. So to do that, we simply interchange the x in the Maclaurin series with 3x. So we get this expression, and of course then that simplifies to 1 plus 3x. This is 9x squared over 2, and then 9x cubed over 2, and 27x to the power 4 over 8, etc. So that continues. And once we've got that expression, we can now use that to simplify the expression that we need to find the limit of. So that's just dividing by x squared to give us 9 over 2 plus 9 over 2x plus 27x squared over 8. So now all that remains is to take the limit of that, and we can see that the limit of this, well, everything which contains x or anything greater than x in terms of a power, so x squared, etc., onwards, will tend to 0. So all of these will tend to 0, meaning that this limit is equal to 9 over 2. So we can say therefore that e to 3x minus 1 minus 3x over x squared tends to 9 over 2 as x approaches 0. And that's really something that we couldn't have told from the initial expression. So let's see that on the graph, and indeed the point that the graph crosses the y-axis we can see now is equal to 9 over 2. Well, that concludes this video on the application of Maclaurin's theories to limits. In the next one we'll be looking at L'Hopital's rule.